Hello everyone. Welcome to the session Intro to Blockchain and Tezos. So we'll be joined with Thakur Patel soon. In the meanwhile, I'll just share what we have in plan for the next few weeks. So this is the first of the many events that will be happening, and the first is the introduction session. It will be followed by a building session in the coming weeks, where you'll be learning how to build your first smart contract. And the simplicity of it is because it will be built using Python preferably. And so most of you, as I've seen on the response, are comfortable with Python or JavaScript. So that's why I prefer that we do it that way. And in the meanwhile, in the third week, we'll be try to build some projects, and you'll be assigned the assignments accordingly. And as mentioned, there will also be a few giveaways during the coming weeks during the workshop. So I'd recommend that all of you attend those events, and also please follow all these events. Now a little bit about Thakur Patel. So Thakur Patel is the lead instructor for the Tezos team, and he's also the winner of Ether Punks 2021, and also the recent hackathon by Solana, Building Out Loud. Also, Thakur Patel has also won the Tezos India Fellowship for this year. So you know the credentials are good for that person. So I think Thakur has joined. Yes. Hi Thakur. Okay, so Thakur, whenever you're ready, we can start with the session. I've given you the host permissions.
Hello, everyone. So let's not waste much time, and I'll get started. So yeah, before that, do you guys know what about Tezos? What Tezos is? I mean, has an introduction been given yet?
Yeah, a brief introduction has been given. With the session, everyone has come with a beginner's mindset. So we can,
All right. So let's just dive into blockchain. So I'll be sharing the screen. Yep. So blockchain. First, today's discussion. First, we'll discuss blockchain. Blockchain, in a way, is called the Web3 technology. That's Web3 means Web 3.0. It's something which is a very trending, and you can, if you go through your Twitter anytime, you can understand the impact of this technology in our current society. Why everybody is running, head over heels for people with Web3 skills. So Web 2 companies would be like all the FANG companies which you have heard, Facebook, Amazon, Netflix, or any like any bank right now, like JP Morgan, Goldman Sachs. All these are Web 2 companies. Web 3 companies would be more like people working in the Web 3 space, for example, would be Polygon, would be Solana, would be Tezos. These are all like a blockchain. These are like foundations, right? And then their companies were built. These are like blockchain networks, and then there are companies which are built on top of this blockchain networks. For example, let's say this Ethereum blockchain, and there's an app called Decentraland, which builds a metaverse on top of Ethereum blockchain. I mean, yeah, you will get to know more about it. Like, this is just a brief introduction, not technical part, just, from above a bit, general knowledge about the blockchain technology and the ecosystem. So you don't have to feel worried if you haven't heard of these terms before, because that is the goal of the workshop. I'm going to tell you what these terms mean. And by the end of the workshop, we'll understand what Ethereum is, what Tezos is, and how and what is the blockchain, and how a product's built on top of blockchain, and how a blockchain is built. Right. So if anybody has any questions, you can just type it in the chats anytime. If I think you have permission, I'll be taking. You can interrupt me anytime if you have any questions, because I believe that's the most efficient way in which I can, in which I can transfer my knowledge to you. So let's proceed. After that, you'll understand a bit of the cryptography basics, because cryptography, blockchain is basically, you can say, it's an advanced application of cryptography. It's a very beautiful application of cryptography, which makes it more practical. Because normally when you say cryptography, like, as a person, I'd understand, yeah, dude, this is like cryptic, and I'll think of, let's say, angels and demons, or like the Da Vinci Code, when you talk about cryptography to me. But what computer scientists have done is they transferred this cryptography into something practical, something which can be applied, something which can make money, in a sense. So the blockchain is it's a practical application of cryptography. After that, we'll have a proper introduction to the blockchain, and then I mean, I've been saying blockchain, blockchain, blockchain a lot, right? Till now, I don't know the number of times I've said the word, but let's say you're building a project or you're participating in a hackathon, right? So, what the question which comes to your mind, which should come to your mind, is, do you even need blockchain? And if you need them, when do you need them, right? Because not every the companies, they build solutions to problems, right? And not every solution requires blockchain. So you should not, I mean, like, right, you should, so based on your problem statement, you will identify, based on the problem statement, you'll identify whether you need a blockchain or not. Before this, is my voice like audible clearly, or is it lagging?
Or yes, it's clear.
It's clear? Okay, thank you.
Guys, if there's an audio issue, can you yeah, just type it in the chat if you're facing?
Yeah, if you're facing any issue at all, if you cannot understand something, if you have audio issue, video issue, anything, just type it, and I'll explain that thing again. I'll go over that part again, right? So after I go through that, we'll finally go through an introduction to Tezos. After understanding what a blockchain is, we can clearly understand what Tezos is. So before that, this is a bit about me. I've participated in many hackathons, and I've also been speakers at international events, outside India, and I'm currently solving problem statements in the blockchain space. And if you and I'm going to teach you about that today, so that you can also start your journey. First, what comes to your mind when you hear the word blockchain? I need answers from you guys. I'll see the chats now. Come on. For those of you who have heard of blockchain, what do you think a blockchain is? I mean, it's fine if you're wrong. You just need something. A way of storing data. That's right. That's a way of decentralized way of storing data, Shivam. A chain of data blocks. Right, Tejas. I mean, it's chain of blocks. Bitcoin. Yeah, Prachi. Like Bitcoin and blockchain, they are well associated with each other. I get that. Huh. But they work with each other. Where Bitcoin is an application of blockchain. There are many applications, and Bitcoin is one of them. A cryptocurrency, a currency which, can you imagine, such a currency which, a currency is usually regulated by some governing body, and but here you just eliminate the governing body by using practical applications of cryptography. So that's a beauty in itself. Immutable hyperledger. Okay, yeah, it's an immutable ledger of data. That's true. True. And what else do we have here? Formation of chains connecting blocks consisting of various info, Rakesh says. Yes, it is. You can explain it like that. Way to connect secret data. Yeah, I mean, like, they have different computers which are connected to each other. chain of data storing facilities. Okay, so there's a lot of people with answers, and this is going to be a very interesting workshop. I see. A lot of you have an idea about what a blockchain is in general, and that's awesome. That's a great start right now. So let's proceed. Awesome. I mean, most of you gave correct answers. I mean, like you understand the crux of blockchain in a way or the other. So let's just go ahead. So, what is a blockchain? It's a like in brief, you can say that it holds transactional records because the records which you talked about in the chats, like you said, it holds data. Then the data which we're talking of here is transactional records. Like when I say a transaction, let's say there's a bank transaction. Let's say like who said let's say Vedang gave the last ones, right? Let's say that I want to give like 5 Bitcoin to Vedang, and then so this is a transaction, okay, and this transaction is going to be recorded in the blockchain, and that is what is stored. Transactions, or like let's say I give money to Vedang, and let's say Ayush gives money to me. All these transactions, or let's say Jatin gives some pesos XTZ to Swapnil. So all these transactions are recorded in the blockchain, and they are stored in a decentralized manner. So that's a system. It holds transactional records, and these records cannot be edited. Like once it's done, it's there. Nobody can change it. Nobody can falsify it. It's there for everybody to see, and it's transparent. And these are like different properties of the blockchain which we'll go through. Okay. So a system. So a blockchain is a system that holds transactional records. While okay, Vedant, can you hear me? I mean, like, is my voice audible again? Vedant says that he can't hear anything. Okay, try increasing your volume. Okay, Vedant. Cool. I'll continue. So it holds transaction records while ensuring security, transparency, and decentralization. By security, it means that nobody can tamper any data, right? Let's say that there's a transaction. Normally, if you were to trust your transaction, if you were to trust holding transaction records, here a system is holding the transactional records, right? Let's say you trust this to a third party instead of a system, and there can be an entity inside the third party who wants to change a certain record for his own good or for his mischief. He want to do that. I mean, like, but the point over here is that he can practically do that. It is possible. It's not impossible. It is possible that for him to do that. So although they try not to, and they to maintain their the whole sense of trust which they have, they do not do that, but they have. It is possible, right? But when you transfer all this data into a blockchain, then this becomes impossible right now. It's not. It's practically impossible to change any data. So over here, instead of having a third party, you have a system, and this system is called a blockchain. That is why it's called secure, because you cannot change any data which has already been inputted into the blockchain. Right. Then there's transparency. By transparency, what I mean is that all the data in a blockchain can be visible, can be viewed by anyone. And when I say anyone, I mean anyone, right? Like, even if you are part of the blockchain network or not, you can view the data. And how do you do that? Let's currently like they have their thing called block explorers. Like for Ethereum, there's Etherscan. For Tezos, that's better called Dev. I mean .com. These are websites. So the data in a blockchain, it's not like hidden in some central server as it would be as it would be in a Web2 company, but rather it's open for everyone to view. If there's any transaction, everyone can view it. So the thing, but along with this transparency comes an anonymity. It's not like when I say that I gave some money to Vedang, right? When I say I gave like anybody, let's say I gave some money to Herschel, right? So what happens is um, it's not registered as Thakur give to Bitcoin to Herschel anymore. It's like a random account number, transfer of two Bitcoin from one random account number to another random account number. Nobody knows that I own that account. Nobody knows that Harshit owns that account. So in a way, everybody knows that a transaction has happened, but but nobody can say that whose account is this. So it is transparent in a way, but it also preserves your identity. There's an anonymity. And if you want, and you can also build an application in which you can store the account number against a person's name if you want all the names to also come out as in the transactional data. But in a general blockchain, it's only basically like accounts. Accounts is the thing which we'll talk about. Like I don't think we have the scope to discuss about accounts today, but you get an idea of how to study about blockchain development so that you can understand what actually account addresses are in blockchain. They are basic 256-bit integers, 256-bit numbers, right? The hexadecimal 256-bit, and just it's random. So and finally it's decentralization. Decentralization that has been the core reason why Web3 is Web3. Because everybody is a part of it. You're not trusting a central body, but you're trusting a network. You're trusting everybody. Everybody in the network keeps a check on each other that nobody does nobody tries to hack into the network or nobody tries to, falsify any information as what I talked about. The properties of a blockchain, immutable. What does immutable mean? Immutable means that it's unchangeable. I mean, I have just discussed this that you can't change data. Even if you wanted to, you wouldn't be able to change the data. Okay. So Pratibha is asking, can you explain the point two and three again? Point two and three, as in I'll explain the properties of blockchain again. Okay. Immutable, trustless, secure, and transparent. So just be attentive right now. So immutable, you understood that, right? All of you. Next is trustless. You eliminate the need of a central authority, right? So what does this mean? It means that there is no central authority right now. You're again trusting a system of networks in which there is it's not Web two, right? In Web two, you're trusting, let's say, Facebook server. You're trusting, or let's say, you're trusting. If you're doing a bank transaction, you're trusting SBI server. So here you don't have that. You have just a blockchain system, and there's no concept of trust in blockchain because cryptography handles it all. Right. Next is secure. So security is done through cryptography, through private keys. Okay, I think I should turn on my video also. Much better than so secure. So security is like through cryptography, through private keys, and so cryptography. So yeah, as I said, blockchain is a practical application of cryptography, and private keys are something which from which you can get your public key and your account addresses. And this is something very important. You basically you store your private key with yourself, and and this is how and having remembering the private key gives you access to account. If not like randomly, like an account has let's say 5 Ethereum and let's say another account has like 10 pesos or 1,000 XTZ. XTZ is the currency for pesos. So I mean like these are basically stored as in a ledger, right? Like this account has this much. But if you have the password to gain access to that account, that means you have the access to the funds in that account. And private key gives you that access. It's sort of like there's a lock, the private key is the key. Inside the lock, there are many different type of cryptocurrencies, and if you have the key to the lock, you can open it. Next, transparent. Anyone can view all the info on the network. I've already explained this. Can be or okay, transparent. That's common, right? I mean, you guys would have understood this. So Shivam asked a question. Can you know someone else's private key? No, Shivam, you wouldn't know someone else's private key. That's something which you should keep to yourself. I mean, the only way for you to know someone else's private key is if they share it with you. If they don't, then you'll never know. That's it. Okay, so now the base of all blockchain of all the whole blockchain idea, cryptographic hash functions. So, how many of you have studied cryptography before, or have a basic idea of how many of you have ever studied cryptography? Yeah, public key, you know, public key, then okay. A lot of answer is awesome. Priyansh, Navin, and Ashit, Gautam, Pranav. Okay, a lot of you have studied cryptography before. That's a good start you have. So you'll understand so for those who haven't like studied it before, do not worry because it is I mean uh, you'll get to know the concepts which are required right now. Okay, so no worries. We're going to learn cryptography right now, and for those who have studied it, it's going to be a breeze for you this part, right? So cryptographic hash functions. A hash function is a one-way. Also, what is a hash function? Okay, so remember that. No point in asking you. So, a hash function is usually a one-way function which takes an input of any size and returns a fixed size output. Right. So now, what does this mean? Let's say, let's say there's a fixed size output. Let's say that a certain hash function, releases a 256-bit output. Right. And when I say 256 bit, means there are 2 power 256 possible combination of values. That is what it is meant by a 256 bit number, right? If I say that the hash size is 256 bits, means there are 2 power 256 possible combinations of values. Okay? Yeah, like SHA-256, exactly. SHA-256 is what I was referring to, and Harsh pointed that out. So, over here, so this is the final output is this, and let's say like I'll enter anything. I'll enter, let's say, what will I enter? I'll enter Logitech, or I'll enter Google. So the Google is what Google, 6 letters only, right? So that will be transferred into a 256-bit value. So let's say Google will transfer to that much. Bezos would also transfer to a 256-bit value. Even a single full stop would also, once you put it in the hash function, it returns a fixed size output, right? No matter whatever the size, even if it's one character, like one semicolon or one full stop, anything, one exclamation mark, yeah, or this will all transfer to an output of fixed size. In our case, is a 256-bit number. So, and so that is called a same length result. The result is of the same length. And the third point is the result is unique and it can be used to identify the data. So when I say it's unique, it means that a hash function is sort of like a one-to-one function. I mean, you must have read about it in standard 12. Uh, So, like, if I put Tezos in a hash function, and if I put Tezos with a full stop in a hash function, so they are two different inputs, right? They're two different inputs, and since the result is unique over here, and since it's a one-to-one function, they'll give two different outputs. And this output is not like it's not like there'll be some part of it that you'll understand that yeah, I mean, yeah, if you see those outputs and you check the inputs, it's not like you'll understand that yeah, the inputs are almost they have a lot of characters similar to each other. Like Tezos is there in both of it. There's an extra full stop in the other. So if you see the outputs, you cannot you cannot identify certain conclusions like that. The output will be totally different from each other. You would not even expect it to be expect the inputs to be so similar. Even similar inputs, not the same, but similar inputs would give completely different outputs. And that's what a hash function does. Everybody understood till now? Like, are you with me? Guys? Okay. Okay. I thought I started boring you. Okay, it seems that you guys still have energy and attentiveness to listen. So that's awesome. Next, let's go for the properties of hash function. Hiding. Yeah. So you cannot find the hiding. You cannot find the initial value from this value. Okay. You can like from the output you cannot guess what the input is. So in a way it hides the input, and it's also deterministic. Like, and then it's also collision free and it's puzzle friendly. So when I say so this means that basically I've already explained it in above when I explained what a hash function is. Collision free, it's more like uh, two different inputs would never give the same output. Never, right? And deterministic is like you get deterministic results through a hash function. And it's puzzle friendly. Puzzle friendly is something which you will understand later, down later, like when I talk about blockchain, right? When I go into the actual blockchain. So the different types of hash functions which are used are like some common hash functions are SHA-3, SHA-256, as someone said in the chat, and there's KCAC256. So SHA-3, SHA-256, and KCAC256 are used in blockchains. They are mainly that's what's used in blockchain, and the algorithm can be anything, but the hash function should have certain fixed properties, such as being a one-way function and being collision and also collision free, right? So collision free means they exhibit extremely low probability of collision. Means no two inputs will give the same output, and so there are different types of algorithms, like cryptography algorithms. At first, the RSA algorithm was being used for passwordless user authentication, for example, for accessing virtual machine on the cloud, and slowly and that was upgraded, and finally the ECC family of algorithm is used in Bitcoin and Ethereum blockchain. ECC family of algorithms, right? So and the most commonly in blockchains it's SHA-256. That's what you'll be encountering. So yeah, and if I talk about cryptography, like for those of you who studied, I mean, even if you haven't studied, you can search what asymmetric key cryptography is and what symmetric key cryptography is. So in asymmetric key cryptography, there's more like a private key and a public key for each user. Let's say I'm a user, right? Let's say I'm Thakur. I'll have my own private key and its corresponding public key, and let's say anybody else, let's say Vikas, he has his own private key and his corresponding public key, and using those two keys, you encrypt a message and you also decrypt a message. The whole procedure is something, I mean, which you would easily understand if you go and go through one Google search about it. But if I have time today, I will definitely go through, how asymmetric key cryptography works. And the reason why I would want to explain that is because the Ethereum blockchain uses asymmetric key cryptography, and which is also called public key cryptography, right? Symmetric key cryptography is like one key, and asymmetric key cryptography is a pair of keys, a private key and a public key. That's all you can learn for now. So we'll just proceed. Hash functions in blockchain. So where are hash functions used? There's a thing called transaction hashes. Like I told you, like in a blockchain stores all the transaction data, right? So this transaction data is not like directly stored as I told you like our names are not stored. What I told is in a way is money, some cryptocurrency is transferred from one account to another account. That information is stored, right? That information is stored. So it's not directly stored like this, is what I'm trying to say right now. Instead, this information is hashed and then it is stored in the blockchain. So this is why. So this is transaction hashes, and all the transaction they are stored in a tree-like structure. I mean, for those of you who have ever studied DSA, you'll understand what a tree is. And in blockchain, they use something called a Merkle-Patricia tree, right? That is something I don't think you would have gone through, but you can search what a Merkle-Patricia tree is. So what it does is it's like they have values at each leaf nodes. Each leaf node is like the end node. Okay, each leaf node they have a they store a transaction, and you start hashing the leaf nodes together all the way till the root, all the way till the the tree, the node, the root node, and then you find a final transaction hash. So what is happening when so what happens is you're hashing two values together. Let's say the right leaf and the left leaf. You just hash both of them together. Yeah, is it it's like binary for hashing? Yep, similar to that. You can say it's similar to that, except you use a multiple Patricia tree here. So it's like you hash each of the left node and the right node, and you find a the node on top. Then you hash it with its corresponding leaf node, and then you go all the way to the top, and you find a final transaction hash. And that final transaction hash, in a way, it's a single hash. It's a single 256-bit number, and that somehow stores all the data of all the 1,000 transactions which are present in the leaf nodes. So this is a very efficient method of storing, transactional records in which you can just have a single you can just have a single 256-bit number which shows the value of 1,000 transactions. Next is block hashes. So I'll show you what block is and what does it store, and then you'll understand what a block hash is. And finally, addresses. So to find addresses, to find not addresses, how are addresses formed would be a question in some of your head. So what happens is, let's say that okay, addresses. I talked about me having address, and then another person, a person who want to give money to, they'll also have an address, right? So how does this addresses work? At first, a 256-bit random number is generated, right? Which is your private key. This private key, you first get your private key, which is a 256-bit random number, totally random. And then ECC algorithm is applied to the private key to generate a public key. So ECC algorithm is again something which I told is used in Ethereum blockchain and Bitcoin. So that is used on your private key to find your public key, right? And after that, hashing is applied to the public key to get your account address, which is a 160-bit number. The hashing is then applied to your public key to find an account address, which is a 160-bit number, and finally your final account address is generated. So I'll again review the process. First, you have a 256, so it's completely easy. Just hear it one more time and you'll get it one more time. So at first you get a private key, okay? You get a private key at first because that's something only you which you'll have. And this private key is a randomly generated 256-bit number, right? And then you got a private key. So, but I told you that Ethereum blockchain uses public key cryptography, right? So now what happens is, and you got from the private key, you get the public key. Now, how you get that? You're going to use the ECC algorithm. Through using the ECC algorithm that's applied to the private key to generate a public key, right? Now you have your private key and your public key. So these are the basic requirements of a asymmetric key cryptography. You'll understand. You can Google about that data. You have two keys. I told you about it before. There's a private key and there's a public key. So after this, hashing is applied to the public key. So private key, you keep it to yourself. Don't show it to anyone. And now you want an actual account address which you can through which you can store funds into it, or and later give funds, and or you interact with any decentralized application. You need an account. You need an account address. So how you do get the account address? Hashing is applied to the public key, and then you get an account address, right? And then you get an account address. So I hope that that's clear for you right now. So questions, anybody? Like even if it's silly questions, I'm willing to take it up. Just don't be shy when you ask. That's all I ask of you, because you've come here to learn. So I hope you do. How do we get private key? That's just randomly generated. I mean, private key is like you access the blockchain, you try to make a wallet, right? Let's say you use an application, you try to make a wallet. So at first randomly like a random 256-bit random number is generated using any algorithm. So 256-bit means there are 2 power 256 possibilities. So you'll get out of those 2 power 256 numbers, you'll get one number, and that will be a private key, and nobody will ever know about it. Private key to 256-bit to ECC algo to account address. Yes, Ashir, right. First private key. First you get a 256-bit private key, and then use ECC algo, and you get a public key. Okay, this is a public key in between. After ECC algo, you get a public key, and from that public key you do hashing, and you get account address. बस उतना ही है सही हो तो I mean, it just generates. It works in such a way in which it just generates, and then it will show it to you, and then it's done. It doesn't store it. Yeah.
think I think the public-private key pair. I think it went a bit difficult for most of the students.
Okay. Okay.
Can we take a simple example, like
Yeah.
most simple, favorite example?
Okay.
Can you tell me?
Awesome. Awesome. Thank you, Taha.
Okay, okay.
So I'll give an example of what asymmetric key cryptography is. Okay. Let's say that there are two people. Okay. Let's say there's me, and let's say Taha. Taha, he wanted to send a message to me. Okay. And how would he do it? So I can call you by Taha, right? Fine.
Yeah.
So at first Taha, he has a message which he wants to send to me. That's the goal, right? And we are going to use asymmetric key cryptography to send the message. So Taha has his private key and his public key. I have my private key and my public key. So first is Taha wants to send the message. He writes the message. So after writing a message, it can be anyone's. So to show it is his, he will digitally sign the message. And how does he digitally sign the message? It's by hashing with using his private key. He digitally signs it using his private key because private key is something private to him. Okay, private key is private to him, and as for the public key, it's more like have you heard, like, have you seen movies in which they're like people have this big thick books beside the telephone which they call address book, in which there's the contact information of everybody over there? Public key is somewhat like this. Your public key, if anybody wants to send a message to you, they'll use your public key. It's visible to everyone. Okay, public key is something which, as the word suggests, it's public, and you share it with everyone so that you can receive messages from them. So now, since I want to receive a message from Taha right now, first he digitally signs his message using his private key, right? So that is called encryption one, encryption level one, E1. Okay. So first he encrypts it using his private key, and then he again encrypts it using since the message is meant for me. So he'll go for the address book, look for Thakur Patel. He found Thakur Patel, and then he found what he finds is there is my public key. So we'll again encrypt it using my public key. So you can think that first he digitally sign or encrypts it using his private key. Then again he does it using first he does it using his private key, Taha's private key. Taha sends a message. He encrypts it using his private key, Taha's private key. And then since the message is meant for me, he'll again encrypt it using my public key. Okay. So this two information is done. And this is the end of encryption. Okay, this is the end of encryption. So now this message is then sent over all the communication system and then it goes to me. So now I receive the message, right, through all the communication system. And if somebody, if somebody, and this is when the message is prone to attack. If somebody is curious about what me and Taha are discussing, let's say we are both like members of G7 and we had some important, we were discussing some important information, and some terrorist group they want to get that information. So they'll get so the data which they get is right now is after encrypting it twice. So what they get is some gibberish data which makes no sense at all. I mean, no sense at all. I mean, it could make sense if they could decrypt it, but they wouldn't be able to decrypt it because they do not know my private key. Only I know my private key. And I'll explain why right now. So the encryption part is done. Now for decryption. So the last encryption was using my public key, right? So public and private key, they sort of a pair. If something is encrypted using my public key, I can decrypt it using my private key. And if something is encrypted using my private key, somebody else can decrypt it using my public key. They're sort of a pair. Okay, they go with each other. So it's already encrypted using Taha's private key and my public key. So now the decryption process starts. So since already it's encrypted using my public key, so at first I'll decrypt that. I'll decrypt it using my private key because I have my private key. Only I know that. So that is why only I am the person who can decrypt that message, and that is how the message is meant for me only. If I use some, if somebody else tries to decrypt it using their private key, it will again give a gibberish message, which makes no sense. So the message was meant for me, so I decrypt it using my private key. So one level of encryption is done. I use my private key once and my public key once. I mean, Taha used my public key in encrypting the message, and I decrypted that using my private key. But it's still not done because at first Taha had digitally signed the message using his private key, right? His private key. He saw his private key and he is digitally signed using his private key. So private का pair क्या है? Public. So now and his public key. Do I know it? Yes, I know it. It's in the address book from which he found my public key. I will again open that address book. I'll find his public key and I'll again use his public key to decrypt the message. So finally, the message is completely decrypted after going through the cycle. And what we get is the message which is originally meant for me, which is Welcome Thakur for the workshop. That is the message. Right. So this is how asymmetric cryptography works and how a private key and public key works. This is the most simplest example which you could bring up to try to understand it. And blockchain technology they use a complicated version of this, right? So let's proceed. I hope like things got much clearer regarding the private key and public key.
Yes, definitely.
Okay, thank you. If there's any questions, you can still ask, and towards the end, I'll clarify. Okay, do not shy away from asking questions. So let's proceed. Okay, so how a blockchain works. Oh well, it's 45 already. I'll try to wrap it up quickly, but I hope to give you the most information as possible right now. I wish we had more time. So how blockchain works? At first someone initiates a transaction, then the requested transaction is broadcast. See, someone initiates a transaction, like as it initiates a transaction, as in I want to give like I want since Taj just spoke up right now, I want to give him let's say 5 XTZ. Okay, so I'll initiate a transaction. Okay, let's say 5 BTC for now, Bitcoin, because that's something each one of you knows about. Then there's this requested. The transaction isn't processed. I just initiate a transaction. So what happens is this transaction goes to a certain block, and the requested transaction is broadcast to a decentralized P2P network consisting of several nodes. So what is it? Decentralized P2P is peer-to-peer network consisting of several nodes, as in computers. So it's like there are many computers which are linked to it towards each other, peer to peer, not to a central authority, but to each other, right? To each other, they are linked. And this is a decentralized system and it's a network. So my transaction is then broadcasted in the network. In that network, my transaction is broadcasted. And then the transaction happens. and how this transaction happened, and all the transactions, like me, there are many people who want to do some transactions, and all these are broadcasted into a certain, into a list of transactions. And after this, a process called mining happens. I mean, mining is it's basically solving a puzzle through which you can, and if you solve any, that's a that's a different concept altogether, and it will take like 15 more minutes to explain that. So I'm not going into that right now. But there's a thing called mining, and Bitcoin mining, you must have heard it. So this mining sort of ensures the authenticity of the system, and it ensures security, right? And there are also incentives for miners. That is why people do this. Without there's no central authority, but anybody can be a miner, right? And there is incentives for to secure the blockchain. That is what propels the whole ecosystem of a blockchain. So after this, a transaction is done, and then a block is validated and approved, reaching consensus by all nodes in the network. So what does this mean? So at first, a new block is created. You're having all the transactions, right? All the transactions. So the block is validated as in there's a puzzle to be solved, right? And let's say the person who solves the puzzle, they win the bet. They get to create the next block, and the reward in getting to create the next block is to get the next Bitcoin mined, right? What they do is they check whether all the transactions are valid or not. Let's say I want to give like 5 Bitcoin to Taha, but I have only 2 Bitcoin in my wallet. So that transaction is not valid. But I can initiate a transaction in which I want to give 5 Bitcoin, but the transaction will not pass through. Why? Because there's insufficient amount of funds. So things like this and other stuff also check. This is the basic thing we just check. When you go for higher level like smart contracts, more complicated things get checked. So things like this are all checked and validated, and this is approved by every node in the compute, every node in the system, every computer in the system, right? So once all of them approve that yeah, all the transactions are right, and the puzzle is solved properly. This is a cryptographic puzzle which all the node gets an opportunity to solve. So all the transactions are valid and the puzzle is solved. Then the new block is added to the existing chain. So this is how it goes, right? So this is how it goes. And after all this is done, then this block is added to the chain, and this is how it will look like. Sure, this is how it will look like. More like this. There's one block, and then that is linked to another block, and that is linked to another block. It's more like a linked list. It's somewhat like a linked list in which you store the hash of one block of the previous block. In this, you store the hash of the previous block, like the hash of block 0 is stored in block 1. The hash of block 1 is stored in block 2. The hash of block 2 is stored in block 3. And in that way, they're linked. So over here, when you add a block, when you add a new block to the existing chain, it's linked in that sort of way. Like if you can see here, like each hexagon is a block, they're linked, like a linked list. One, block 0, block 1, block 2, block 3, block 4, block 5, and block 6. Right. So now what does a block contain? So what does a block contain? Right. So a block contains, let's say there's a head. It contains there's a header. In header, there's a previous block hash. Previous block hash is something which links all the blocks to each other to form the blockchain. And then there's a Merkle tree root. Remember when did I talk about Merkle tree root? If you guys remember, is when I talked about the transactions. All the transactions they are stored finally in a Merkle tree, right? So that also comes under the block content. So there are details like this. There's a timestamp. Timestamp is in the time in which the block is mined. That's stored. Difficulty and nonce is something related to mining, so I will not go through it right now. But that are important information which is also stored in the block, right? And other things like there's a thing called extra data, block number, the gas limit, the gas use, the state root, the receipt root, the transaction root. There are tons of stuff. All these are stored in a blockchain. All of these are stored in a single block. And finally, these all are stored as values, right? So to find the block hash, what happens is you hash out these values, all the values which are just listed, you hash all of them together to get a final hash. And that becomes a block hash. Okay, that becomes a block hash. You can say that 0xabc123 over here. This is the hash. This is the final hash which represents all the data in the blockchain. So Genesis block is more like, okay, Genesis block is written in each one of this, but ignore. This is Genesis block is block 0, this is block 1, this is block 2, this is block 3. So block 0 has this. This hash is stored as previous block hash in block 1. And like that, the hash of block 1 is stored as the previous block hash of block 2. And that is all of this are linked, right? And all the transaction data are stored inside of here. And block is, and the block hash are generated by SHA-256 hash algorithm. I've told about that previously. And this is how all of this are linked to each other, and this is how the blockchain is created, right? So this is about the structure of a blockchain. You understood how blockchain works, like basically how it works, and B, you've also understood the structure of a blockchain, how it looks like right now. A basic idea right now. I mean, I definitely know that you wouldn't have completely understood, yo, I understand what blockchain is and everything. I mean, it will take some effort from your side and some more time dedication from your side, but I hope that this will give you a start, a good start on how to, on studying more about blockchains. So let's come to the major question. Let's say you are doing a project or you're participating in a hackathon and you have an idea. So the an important question is, do you even need blockchain? Why do you go through this question? Because blockchain, although it has a more secure data structure, as many of you had mentioned in the beginning, secure, there is a trade-off. You cannot get everything right, and the trade-off is speed right now. The trade-off is speed. The trade-off is speed is one of the trade-offs, essentially, an important one at that, right? So that is why you need to check whether you need a blockchain or not for a solution. So you go through this flowchart. First, check whether you need a database, because a blockchain is essentially a database. No, then don't use. Yes. Then does it require shared write access? Again, if you're the only person writing, then there's again no point in a blockchain. But if there is shared write access, then continue. Other writers not interested. Yes. So are the writers' interests unified? If there are a bunch of people writing and all of them are already unified to a certain goal, there's no discord between them. Then there's no use of blockchain. You can just go through any normal database structure, right? But if they're not, if like everybody's there and the writers are not unified, they have discord, like they have different views regarding things, then you should go back into the flowchart, right? Do you want so right now that you know that there are more than one writer and each of them do not trust each other, right? Each of them do not trust each other. I mean, they trust, but they can have different views at times. So how do you handle that? Go to the flowchart. You can handle it either using a trusted third party or blockchain. So if you want a trusted third party, there's no use of blockchain. But now, but if you don't want a trusted third party, then you have to use a blockchain. You have to use a blockchain. Okay. So now the question comes on whether it will be a public blockchain like Ethereum, like Tezos, like Solana, like Bitcoin, right? Or whether we have to use a hybrid blockchain. Example of a hybrid blockchain is R3 Corda, or a private blockchain. For example, is Hyperledger Fabric, Hyperledger Sawtooth. These are examples of private blockchain. So you already understood you need a blockchain. Now check whether you need a public, hybrid, or private. This depends on the control functionality and whether you want the transactions to be public or private. So if you want more control, if you want more control and you want the consensus to be determined within a certain organization, then use private blockchain. If you want it between a group of organizations, then use a private blockchain. And if you do not want any sense of control, then go for a public blockchain. So if you want the transactions to be public or for a public blockchain, if you want it to be private, then again, based upon whether it's within your organization or within a bunch of organizations, use a hybrid or private blockchain. Right. So this is how you check whether you need a blockchain or not for any problem. And if you have any questions, I'm telling you, we are running out of time, so you better put it there in the Google chats. So proceeding, there are use cases of blockchain. So one use case is a decentralized finance, like for example, which I just told you about. All the examples which I told you were simple examples about me giving, let's say me giving Bitcoin, me giving Ethereum, me giving XTZ from one person to another, or from A to B, right? So these all come under DeFi, and DeFi is much more than this, more like the liquidity pools in which you can invest your money, and then there's AMM bond curves, automated market makers, and there's stuff. There are tons of stuff. It's basically a replacement of centralized banks. Okay, you're using blockchain right now, blockchain technology, to somehow replace banks. And that is what banks and currencies also. So that is what a decentralized finance is. The next is NFT marketplace. I mean, I don't think any of you here have not heard about NFTs, saying the buzz it created over the past year. So yeah, NFT marketplaces is created by the use of blockchain. What it does is it gives a digital, it gives an identity, a sense of uniqueness to any digital asset, be it a picture, be it a video, or anything. It gives a sense of identity, right? So when I say it gives a sense of identity, it imbibes uniqueness to that. And once you make like a digital art, right now it's like, okay, let's say this current page. If you take a screenshot of it, you own it. And right now I also own it. But let's say, what if this is stored somehow, if this is somehow given a digital identity? There's only one copy of this right now. That is stored in a blockchain. Okay, it's stored in a blockchain. It's registered somewhere in the blockchain as data, as a transaction, and it has a timestamp of its own. Okay, so let's say that you're saying क्या फर्क पड़ता है तो image ही है. I just take a screenshot or better I just right click and I'll download it, right? You say that, so that you can do that, you can download it like that, but I've already uploaded it to the blockchain and it's already there in the blockchain and anybody can check the timestamp and you'll also upload it to the blockchain and you'll try to compare that mine is also uploaded in the blockchain as a mine, but if you compare the timestamps between both of ours, mine timestamp is earlier, means mine is the original product. So in this way it also has a sense of uniqueness to for any digital art, right? And finally, it's supply chain management. So, as I told that here there's no concept of trust in a blockchain, right? Since there is no concept of trust in a blockchain, a supply chain, a supply chain management, a supply chain, there is huge trust issues between all these stakeholders present in a supply chain. I mean, if let's say if there were you're transporting 1,000 goods and somehow 10 goods disappear from somewhere, I mean somebody has to be responsible for it. And this allows and use if you use blockchain over here, you like let's say use a blockchain over here. Like every time a transaction, every time a goods reach a place, you enter all the data into a blockchain, and it's decentralized and anybody can see every time. And the thing is, nobody can change the data. So here is whenever there is a discrepancy, like whenever uh, there is a loss of the goods, you can identify the exact spot and you can held and you can hold a certain stakeholder responsible for the missing goods. Right. This is one of the use cases of a of blockchain supply chain management, and that's one of the use cases of blockchain. Other than this, other evolving use cases are metaverse and GameFi. Metaverse, uh, blockchain is used for to enterprise all that digital assets because it contains a lot of digital assets. All of this are given identity using NFTs and use a cryptocurrency to let's say buy and trade stuff in the metaverse, right? Good. So that was about the use cases of blockchain. And what I talked about was simple transactions again, like me giving certain money to some other person. But if you want to build more advanced concepts, like which I talked about in decentralized finance, for example, you want to build a decentralized exchange. You know what an exchange is, right? An exchange is let's say like there's a Binance, it's a centralized exchange, or let's say there's any the Zerodha also. These are all exchanges. So if you want to build a decentralized exchange, you can do so using smart contract. So this is where programming comes. So so that is one high-end use case of a smart contract. One low-end use case would be like, let's say you have a bet with a friend, and let's say that there was an IPL match yesterday. It was like I think RCB versus Sara, and you just bet. Let's say one of you is a true RCB fan. RCB जीतेगा इस साल का अपना दे. So what happens is you can instead of have you bet like you want to bet 5 Bitcoin on it, whoever wins it. So instead of having a verbal bet, you can put it in a smart contract, right? You can code it in such a way that if let's say first both of you give your respective funds like 2.5 Bitcoin, 2.5 Bitcoin, or 5 Bitcoin each, okay, and whoever wins takes the money all. So what happens over here is you don't have to trust any third party. The smart contract it is written in the program and it will automatically transfer assets to the winner based on the data it gets as who won the IPL match. So you can code like things like this without you. So you can do things like this without trusting a third party and just using a smart contract. and they're advanced users of the smart contract, and this is what blockchain development, and this is what blockchain developers do. They write smart contracts, and the better smart contracts you write, the better for blockchain developer you will be, right? So this is something very, very important. Next, lastly, let's just learn a bit about Tezos. So the native currency of Tezos is XTZ, and it's an energy efficient algorithm. There's a proof of stake. So the proof of stake and proof of work, they're like different algorithms right now. Bitcoin and Ethereum currently are proof of work, and which requires a lot of electricity. You must have heard articles about that. But Tezos, it is different. It uses a proof of stake algorithm, which is very energy efficient because it does not require as much energy to execute. And you have to Google about this because I see that we have run out of time, so I cannot explain you the different proof of the different algorithms which works. Like there's proof of stake, proof of work, and the liquid proof of stake. That's the liquid proof of stake is what Tezos use. So this will again require another session if I were to go into it. So after this, there's upgradability, seamlessly, forklessly. I mean, forking is something again which is a high-level concept, but just remember that Tezos is a self-upgradable blockchain, and there are smart contracts over here, and there's an on-chain governance. Let's say if there's any change which you want to have in the protocol, it happens on itself, right? It happens by itself, like it happens on itself. Okay, cool. So I get the ending was a bit rushed over here, and there's some things which you might not have understood, but I'm confident that I'm giving you the base to learn more about blockchain. For those of you who are interested, you can read more about the terms which I told you about. I given you a basic idea of what those terms are, and you can start reading about them. Many articles available on the internet, and since now you know the direction in which you have to go, the terms which you have to Google, I believe that you once you start learning about blockchain and blockchain development, you would it would ease your journey by a lot, right? And throughout your journey, if you have any problem, you can contact me. This is my Twitter and my LinkedIn profile QR codes. And I see that there are like around 70 people in the meet, but not, but a few people, I mean, a lot of people answered. That's amazing. I mean, I do not get this much response in other workshops. I'm very happy to receive a lot of questions during this workshop. So for those, but still for those shy people who didn't ask any questions, you can DM me in areas of my social media. Thank you and welcome to Web3.
That was a great session, Thakur. Also, guys, if you have any doubts, do follow him. Like as we mentioned in our tweet, like, he is a crypto chat. So yeah, you can follow him. And also, we'll be sharing a list of curated resources that we have created. So if you have any doubts, you can have a look at those videos as well. They're already available on the internet. Plus, many of the seniors we have, experienced that, and we have, found the right resources or kind of the resources which helped us. We'll be also be sharing with you in that group we had made. And if you have any further queries, you can ask on the group or you can even DM Thakur Patel. Or you guys, most of you guys have my number as well. So any doubts, you can DM any one of us. So that's not an issue. Also, you guys must have joined the Discord server as well, right? You can also freely ask your doubts there. So there are multiple, sources where you can ask your doubts. So no need to shy away. Ask your doubts. And Thakur, thank you so much for doing this. It was an amazing workshop. I think even I got a lot of insights even after being in this space since a year. I got to know a lot about a bit better clarity on things. So thank you for that.
Awesome. I'm glad I could be of help. Thank you guys, and
Also,
I
if
hope you
you
enjoyed
guys
the
have
workshop.
any questions, you can still interrupt.
Yeah, I'm here for now. Okay, so Gautam asked
Yeah.
hybrid blockchain, private blockchain, right? Yeah, that's well. I could just give right now examples of what hybrid blockchain and private blockchain is. So as I said, it comes on whether you want the transactions to be publicly visible to everyone or you want it to be only visible to the people of your organization. So based upon that, there is private blockchains in existence, and there are hybrid blockchains in existence, and you can choose which one to use. Not everything has to be public, right? Let's say, for example, the supply chain. You do not like. It's fine if the stakeholders have all the information, but I want to pertain it to those particular individuals only. I do not want the information of my supply chain to go to everybody out there. I mean, if not, my competitors can see about what I'm ordering and what's going through, and they can beat me in the market. I would not want that. In those situations, I'll prefer a hybrid blockchain rather than a public blockchain. Okay, Gautam? I hope that answered your question.
Uh, Thakur, do you want me to wait for a few questions or should we wrap up? I
We
think we
can we
can
can
wait
wrap up
till
right now.
4:10.
Yeah, it's
Let's
already been
wait
done.
for. Okay,
Okay.
okay, yeah, sure. So, guys, thank you for attending the workshop. There are a lot of workshops lined up with building on Tezos, so you can kickstart your journey, and it will be a complete package. Where you will be, like right now you got the perfect intro to blockchain, and as you explore, like as Thakur might also agree with me, sessions might give you an intro, but if you want to go into the depth and reach the peak of any skill or any space in the skill in the blockchain space, you'll have to do your own research and you have to do your work yourself only. No, like even Thakur is he spends 20 years, he cannot perfectly spoon feed you anything. You guys have to go out there, Google stuff, build some stuff, and also we have over the next month we have planned stuff so that we help you out in building new stuff and building your career in blockchain. And we also have a few sessions lined up where not specifically coding, but you can also delve into the non-core part of it. So that's not an issue. So stay tuned for the next events. Also, thank you for attending the workshop. Next up.
Thank you guys, and I totally agree with what Taha said. You have to give your own efforts to be a good blockchain developer in the field, and there are multiple areas other than development in blockchain. I mean, marketing is very important. Taha, you agree with me in that also. So,
Definitely, definitely.
so you guys can find your niche and see what you can do in the space. So all the best to you, and I'll bid you farewell.
Thanks, Sagar. Bye.
Thanks.